Hello, welcome. I'm Philippe Kruchten, and I'll be speaking about the role of the software architect. I've been an architect myself for a large part of my career. I've been recently a prof in a Canadian university, and I've continued to do some consulting. I switched several times between academia and industry. I started to be an architect a long, long time ago when I was at Alcatel developing telephone switches. And then I was a consultant in software architecture at Rational Software for about 20 years. I'll be taking examples today from one major project for which I was the lead software architect, the Canadian Air Traffic Control System. And now I've been retired and still live in Vancouver in Canada.
Hello, Neil.
Who are you?
I am the architect. I created the Matrix. I've been waiting for you. You have many questions, and though the process...
Okay, what are we going to cover? I'm going to speak a little bit about how I define software architecture, just to make sure that we're on the same wavelength. I'll be exploring a little bit my example of the Canadian Air Traffic Control System, but the bulk of the presentation is about the role of the architect. What do architects do? How do architects communicate with other stakeholders, other participants in the software development process? And in general, what do they do on a daily basis, which is very often mysterious when you are coming from outside. So we're going to speak about architecture. Architecture is a word that is a little bit overused recently. You may hear system architecture, enterprise architecture, solution architecture, service-oriented architecture. Well, the architecture that I'm going to speak about is what was defined in ISO 4210, the fundamental concept or properties of a system in its environment, embodied in its elements, the relationship, and the principle of its design and evolution. This definition is a little bit abstract, so I still refer very often to the one that we had in the rational unified process. Software architecture encompasses the set of significant decisions. That's important. You're making decision choices, so it is about design. What kind of decisions? Well, mostly about how you organize the software system, how you select the elements, the structure, define the structure of the system, the elements and the interfaces between these elements. But it's not just the structure, the static structure at compile time, the one that you can see when you look at the code, but it's also behavior at runtime, and how the various elements collaborate dynamically over time. And in a large system, this is almost recursive. You have compositions of systems into larger systems. But this definition doesn't stop here. There's also some other notion that comes into play. The notion of having an architectural style, trying to guide the more detailed design in a uniform and consistent way. Software architecture also is not just focusing on the code, the structure, the behavior, but it looks at mapping these to the requirements. So we have to be very concerned about the functionality, how the system is being used, about the performance of the system, about the resilience of the system in the presence of external events, errors, crashes, and things like that. Reuse of part of other systems. The system must be understandable by a large number of people, if only the developers that will actually flesh out the complete system. And taking into account trade-offs on the economic and technological side. Some people, like my friend Grady Butch, even wants to put into that aesthetics. So I'm going to use an example, which is a system for which I was the lead software architect, the Canadian Automated Air Traffic Control System. I've been focusing mostly on one instance, but the system that we were trying to build was supposed to be the start of a product line of multiple systems. And actually today the system is deployed in quite a few countries. But its initial development was to be deployed in Canada only. When I arrived on the project, it was estimated to be a little bit less than 1 million lines of code in a language that you may never have heard of called Ada. And there's a little bit of C++ here and there. Initially, we were targeting at a system that would be highly portable across multiple type of workstation, multiple type of hardware. The system is highly distributed. It's distributed over the country, and in each site, it's distributed over multiple computers. Big government project, $800 million, and about 150 software developers were involved. I spoke about context a little bit earlier, and this is important to keep in mind. You know, there's a lot of things where the recipe depends. It depends on the context. It's very difficult to find recipes and definition that applied uniformly across whole software project. So how do I define context? I have this little rule of thumb, you know, my octopus, as a friend of mine called it, looking at size of the project, criticality, you know, what is the impact of failure? What is the age of the system? Is it greenfield development or is it brownfield development? Are you evolving an existing system or creating one brand new? What is the rate of change in requirements? Are requirements very dynamically changing, or are the requirements relatively stable over time? What's the business model? What's the money flow? How are you being paid for developing that system? Is it, you know, a startup company developing a brand new system using angel capital and venture capital, or is it a government contract between a government organization and a large software development company? Is there a stable architecture? We'll come back to that. How distributed is the team? What is the governance of the project? If we look at the Canadian air traffic control system, that's a little bit what the context is. So size, well, it's about 2 million lines of code today. Criticality, pretty high. If the system fails, hundreds of people could die. At the time I started, there was no legacy system to be reused. So this was pure greenfield development. The rate of change, well, the requirements were pretty stable. They were not very well understood, and we had to do a lot of work to actually better understand the requirements in order to put an architecture in place. But it's not like people have new ideas about how to control air traffic, you know, every week. So the rate of change was relatively low. Business model, that's pretty complicated. It's a government contract with a main contractor and some subcontractors and some software suppliers and some hardware suppliers. So that was pretty complicated. No architecture at the inception of the project. Team, that was difficult. The team was distributed over 5 sites, covering 3 time zones. Fortunately, as I shall describe in a minute, we were able to group all the architectural effort onto one site. And then the rest of the development was done over 3 sites. The governance of such a project is pretty complicated, and I will not dive into that today. When I arrived on the project, there was 1 main contractor and 4 subcontractors on 5 sites, and this in some way defined the architecture. The naive idea they had at the time is that each of the contractor would develop their piece of software and some magic glue would come and put it together. To make things worse, the project was done under a waterfall approach where you would do requirements first and then design. And then when you have a design, then you would start writing the code and then you would integrate. So this in 92 was not working too well. They had piled up a lot of requirements, not a single line of code, no idea about an architecture. And the Canadian government withheld $80 million payment to the prime contractor saying, this project is going nowhere. So we had to press a big reset button in 92, and that's what brought me into this project. That was brought me in Vancouver. So we moved all the teams on one side so that people could have better communication and collaboration. We adopted an iterative development process, you know, design a little, build a little, test a little, design some more, build some more, test some more. We use an object-oriented approach. That's nothing new for people your age, but in '92, that was pretty novel. We created an architecture team that would actually take charge of the architecture of the system and the key technological decisions, and trying to glue the 5 teams together from a technological point of view. We had to restart the requirements gathering. The requirements were expressed in some very strange form that made it very difficult for software developers to understand what the system would actually do. It's not that they were wrong, but they were described in very abstract ways. And we did something that would become a part of the agile movement. We brought some customer on side. We brought some expertise by bringing air traffic controller, working closely together with the software developers. And once we had put that, we were able to convince the government to proceed with the project, although the project had taken quite some delay in that incident. The architectural effort in a large software project like this has to occur relatively early in the process. In the rational unified process, there's this phase called the elaboration phase, where the majority of architectural design activities happen. But this elaboration phase can be broken down into 1, 2, 3, 4 iteration, building software gradually and validating that your design decision about the architecture are the right decision, and that the prototype that you have of the system will be able to evolve into supporting the whole system. So there were internal releases of the system at regular interval. The system by today's measure was not furiously iterative. We had 3 iterations, 6 months each in the elaboration phase. That would be followed by 4 iterations in the construction phase to actually flesh out the system until you have a first beta version, and then some beta versions and some transition to the actual system. The team will evolve gradually with this. From an initial small team during this elaboration phase to design the architecture, we had the team split in 3. A management team, a small architecture team that started with 1 person and grew up to be about 12 person, and a prototyping team that would actually build an architectural prototype and validate it and build up some test harnesses around it. And then when at that start we had finally an architecture in place that we could solidly validate, then the prototyping team was broken down into multiple implementation teams. Some were focused on some features of the system, and some were more focused on the infrastructure of the system. The architecture team itself was reduced. There was still an architecture team until the delivery of the system, but mostly doing coordination and touch up to the architecture. The bulk of the architecture work was already behind us. And there was an integration team that would receive all the work done by the various feature and infrastructure teams and integrate the system in a sort of continuous fashion, pretty much what people have done more recently. So that's to set up the stage of my example, but let's look at the role of the architect. Everybody wants to be an architect. In the Dilbert cartoon that was made visible, this one, I don't see any date on it. I forgot. It's around 1985 or something like that. What's the role of the architect? Well, Roman architect Vitruvius Pollio wrote about it 2,000 years ago. And he said that the architect, basically it's a multi-talented person. He has to be a skilled draftsman, a mathematician, know about history, understand philosophy, acquainted with music. I have no clue why, but that's probably pretty good. Not ignorant of medicine. And basically, he was looking for somebody that knew everything about everything. Role versus person. This is important. A role is defined by activities that a person has to do, responsibilities over certain artifacts or work product, competencies brought in skills, know-how. And persons, they have some competencies, but they also have some availability and some taste and some interest, and also cost associated with the person. So when we are speaking about the software architect, we have to think, are we speaking about the role software architect or about the person? Well, we have to map role to person. And it's a little bit like wearing a hat. If you have a small team, you may have to wear multiple hats during the day or during the week. If you have a large team, then maybe you're wearing only one hat. And the same thing happens with the architect. If you have a small software development team, there may be no architect, but somebody has to play the role of the architect and make architectural decision by wearing an architect hat for a while. Maybe it's the whole team who's brainstorming in front of a whiteboard in a meeting room. They are the architect. At the other extreme, on a large team, you have one person whose role and sole role is to be the architect. And in a very large team, you may even have a team of software architects working together. This was the case for the Canadian Air Traffic Control System, where I started as the one architect, but after a few weeks, I was joined by 2, 3, 4 people. And after 6 months, we were 12 in that team, playing the role of software architect. So remember, you may not have a software architect in your team, but there are people who are playing the role of software architect. Or you may have a person who has software architect written on a business card, or you may have multiple people playing that role, and there's a whole team, hopefully, working closely with you. So what are the roles of the architect? Well, there's multiple roles. They have to be visionary, shaping the product. They have to make choices, so they have to be designers. They have to communicate with multiple parties. They have to troubleshoot the project when things go wrong. They have to make sure everybody is well aligned. When a visitor passes by, the CEO of the company will ask the architect to come and make some presentation. And in my experience, being a consultant in software architecture for many projects, very often the architect have to do some cleanup behind project managers and developers. I captured that in some ways on the Canadian Air Traffic Control System in order to make relatively clear to everybody, because the concept of software architect and software architecture were relatively new in those years. I had a charter for my team. And the charter was a few pages, but this is the headlines of the charter. So defining the architecture of the system, this is obvious, you would say. While maintaining the architectural integrity of the system, that's more difficult because very rapidly, especially when you have a large team and that team is not co-located, different teams start making design decisions that are not quite aligned with the original ideas of the architect. Assessing technical risk, this is a project management perspective, but it's, the technical risk, the architect are well placed to actually identify them. Working risk mitigation strategies, participating in project planning, defining the content of iteration in the future, and just being consultants for design issues with the various design teams. In a commercial company, the architect will also be associated with product marketing and future product definition. Many years later, Simon Brown wrote something pretty similar in a very interesting document. By the way, I'll make available the various documents that I'm referring to. This was in InfoQ, a very useful online magazine. And he had a very interesting paper called Are You an Architect? And he sees two main functions of the software architect. On the left-hand side, you have definition of the architecture, technology selection, architectural evaluation. And on the right-hand side, you have delivery of the architecture. The architect is not just making a few decisions and running away. The architect is stuck with the project until you actually deliver something. So he added things here, management of non-functional requirements, all the quality attributes like performance, response time, availability, and security, they are very often missing or not very well understood in the requirements document developed by business analysts. On the delivery of the architect is also involved in quality assurance, making sure that the system that's being delivered is fully functional and well tested. Another interesting gentleman in our field, Martin Fowler from ThoughtWorks, had this view on the role of the architect. And he says there's two styles of software architect. There's the architecture reloaders on the left-hand side, who's the maker and keeper of big decisions. That's the person who looks outside of the project to the requirements and available technology. The gatekeeper also protects the project from too many intrusion and disruption from the outside world. And then you have another kind of architect that's much more focused on the inside of the project and is a mentor for the various software developers and software development teams, implements and try out the architecture as the architecture is being developed. So a person that is much more code-facing. And he calls that, for some funny reason that I will not dive into today, the architectus rises. On a big project, you need both. You need some architect that are the architectus reloaders and some architect that are architectus arisers. Some focus on communication with the outside world and understanding of the trajectory of the system, the vision of the system, and some much more focus on making the system work. If we look at the Canadian air traffic control system, remember we had this architecture team that worked for a year and a half building this prototype. Well, that's where the architectus reloaders were. I was probably the chief architectus reloaders. The architecture arisers were in the other team. And when the teams were broken down and the architecture team was shrunk a little bit to go down to about 6 people and then 3 and then 2, the architectus arisers became the technical lead of the other teams. So there is this internal focus, architecture definition, technology selection, and architecture evaluation. This is focusing on the system, focusing on the code, making sure that you have an architecture that can actually support what you're going to do. And there is this external focus, looking at non-functional requirements, collaboration with other entities, and looking at quality assurance. So that's what an architect would have to do. And this has to be tailored depending on your context. Small project, large project, safety critical project. There's a big variety out there. So what kind of skills would the architect need to bring into a project? Well, architect needs to be capable of abstract thinking, but not at the expense of small details. And you need to have people, at least some of them, who are big picture people. They have a good knowledge of the domain, a good knowledge of software engineering, a good knowledge of the tools and techniques that may be brought in the project. The second thing is an architect must be an excellent communicator. You'll have to make presentation and you'll have to write documents and you'll have to moderate and negotiate and listen. And so it's for the less introvert of us. Something that I discovered pretty early in my career as a software architect, you must be able to be capable of coping with ambiguities and contradiction. We software people, especially when you have, like me, a strong mathematical background, wants to have things that are clear, neat, unambiguous. But unfortunately, it's not proceeding like that. There is long periods of time where there's a lot of ambiguities and contradiction. And this needs not to be, making you too anxious. So another thing is multitasking. Architects will have to be able to manage and handle multiple concurrent issues. You know, every day there's a new issue that comes up. There's a new person to interact with, a new team, a new entity, a new company, and you cannot get to conclude on one issue. You do a little bit of progress on one and a little bit progress on another one, and then some step back on another one. And this also is pretty difficult on the mental aspect of the software architect. And therefore, you have to be able to rearrange your priorities very dynamically, almost at the day-to-day basis. Another thing that I found difficult when I started to be an architect is you'll be pushed to make decisions. And sometimes you'll be pushed to make decisions very early when you feel that you haven't really understood completely neither the problem nor the solution. But you need to make some decision in order to enable other people in the team to make some progress. So you'll just have to accept that, and you'll have to accept that you're making suboptimal decisions in some cases, and that you will have to backtrack. Someday you'll have to sort of face the team and say, sorry, guys and girls, you know, I was wrong 3 weeks ago. This was a mistake, let's backtrack. And I found that some engineers don't like to backtrack. They'd like to make sure that they, you know, whatever they had in mind they'll try to make it work by using some workarounds. Well, if the decision was wrong, you'll need to backtrack. At the same time, you cannot just be a weather vane. You know, you need to have some strong conviction and express your conviction. Otherwise, people will make you backtrack constantly. And you need to have a balance of knowledge. You need to understand the technology very well, maybe not every single piece of technology, but you need to be able to review the work done by others on the technical side. You need to understand very well the development process that is being used in this project, and very often you'll be asked to contribute to that development process. But also, and that's a little bit more difficult, the architect must understand the domain. And you may not be a domain expert. I had a little bit of an understanding of air traffic control. I'm a private pilot. I flew in France, in Sweden, in the US. So it's not like I was a total novice. And that was a little bit of a problem on the Canadian air traffic control system. This is why I tried to make sure that the architect had some good understanding of what an air traffic controller does, what an air traffic control system looks like. And they made, you know, training session with the air traffic controllers. And we brought in some air traffic controllers, some retired air traffic controllers to be part of the team. So sometimes if you don't understand the domain, there are ways to make sure that the domain expertise is brought in to the architect or the architecture team. So you need to strike a balance with your architecture team between development, process, technology, and domain knowledge. So that can be a starting point for your architect or your architecture team. Remember, it's more than just defining the architecture of the system and running away. What do architects actually do on a day-to-day basis? Well, so in my view, the ideal architecture team spends about 50% doing the architecting, doing design, making choices, validating those choices, selecting technologies, prototyping it, documenting it. So focused on the architecture. And about a quarter of the time, they may be looking outside, looking at users and requirements and other architectures and new technologies. So bringing information into the project. And then about 25% of the time, a quarter of the time, they'll be providing information to other stakeholders, briefing newcomers in the project, part of an onboarding process, briefing subcontractors, briefing the various development teams. What's happening when you don't do that? Well, there's a few cases that I've seen where if the architects spend way too much time just architecting, but do not communicate very well with the outside world will evolve, you know, them and leave them aside. If you don't communicate with the software development teams, the architecture, they'll make their own choices. And if you're not looking outside for solutions and requirements, you may miss quite a few things. On another hand, that's an architecture team that's probably not doing enough architecture. They spend a lot of time traveling the world and looking at software architecture conferences and other architecture. Maybe the team is not staffed enough. I don't know. And you may see different discrepancies. This is a team that's probably doing pretty good, but they're not communicating the architecture well enough to their other stakeholders. And this is one that doesn't look outside enough. And maybe they're going to miss some important requirements or some evolution of the market out there. The architects do not operate in a single closed little bubble. So they have to interact with a lot of people. Actually, they are at a communication node in the project. And they have to do all kinds of trade-offs between functionality and cost and skills and quality and complexity. So the architect has this balancing act to do. There's all these people, the end users, the customer, the support people, the development manager, the maintainers, the system administrator, they all have some concerns. And the architect has to balance which of those concerns he can or she can address. So this is a little bit complicated. So let me simplify it a little bit. There are three key relationships. How the architect communicate with the business analyst? How do the architect communicate with the project manager? And how do the architect communicate with the developers? Business analysis is, that function in an organization that defines the requirements, that brings you what is the system supposed to do. The project manager, well, it's, if I can use a film metaphor, what I call the Hollywood metaphor, in a movie, you have a director and a producer. The director is in charge of the story, the script, the set design, the costume, the actors, directing the actors, shooting things, editing things after the shooting, while the producer is in charge of the plan, the budget, the resources, the staff, the communication between the staff, external affairs, logistics. Well, they need to work together, the director and the producer, to produce a movie. And they have their responsibilities, and there is some overlap and interaction at multiple points in time. A little bit like that in software development. The architect is that node between the analyst, the project manager, and the developers. And that's the interfaces that are very important and very important to keep in mind. Because if you ignore something bad will happen to the project. Now, this is not an organization chart. There is other communication in the system and some reporting. Probably everybody is reporting to the project manager. But there are key boundaries here. I'm oversimplifying the thing. Here by analysts, what I speak about is requirement engineering, product marketing, customers, domain expert, people that have some legal implication. By project manager, there may be communication with subcontractors, there may be unions, and there's all kinds of people that are hidden there that drive something. And developers, well, there's also not only the developers that are working in the project inside the company, but the subcontractors and the technology vendors. So what's the interface between the architect and the analyst? Well, you might think that the analyst will provide the requirement, but it's actually much more complicated like that. The architect receives the requirement, but a dialogue needs to happen there. The needs are not properly expressed. The non-functional requirements are missing. There are ambiguities and things like that. So there is a useful two-way dialogue happening there. I can even say that in some circumstances, the architect can even offer opportunities to the analyst. Say, you know, the system could also do this. And the analyst or business people would look at whether this is an interesting possible new feature. Between the project manager and the architect, the project manager provides resources to the architect and the developers. There's a release plan, there's a sort of a schedule for development and some milestone, but the architect also push back on project management in terms of workload, work partitioning, how to organize things in teams, development cost, and risk, technical risk, and sometimes also programmatic risk that are pushed back onto project management. On the third interface, the architect communicate a lot with the developers, mostly because they speak roughly the same language. So they push constraints, decision interfaces, structure of the system to the developers, but they get some pushback. They get also some estimate of cost for development, some evaluation, and they get some prototype to validate some of the architectural decision, or at least tentative decisions. So this interface is the easiest to achieve, providing you don't have too much boundaries. The architect will also provide some form of translation between the various groups. The developers tend to speak in terms of software that they're familiar with, and this may need to be translated to the business analyst, and vice versa. The business analyst may use some jargon that may not be understandable by the developers, and a little bit less between the project management and the developers. So there is some translation, but also some coordination. If you start having distance, I mean physical geographic distance between those groups, so the architect will help a little bit with the coordination of work and the collaboration. So if you have a project that's developed somewhere, but the business analysts are in another city, yeah, you'll get something lost in translation. If the architect and the project manager are in a city and the developers are in another city and the business analysts are in a third city, then you'll have quite some communication problem. So there's the small cohesive team where everybody is more or less co-located, and there is the cohesive team, but with the management that's remote. And sometimes the architects are too remote from the developers, which is pretty unfortunate. Or they may have their favorite developers with whom they speak a lot, and some developers are way remote and they don't speak with them a lot, like this. On an organization to day-to-day basis, what's the process for designing an architecture? This is something that is pretty common, sort of template. You have a backlog. It's not the backlog that you're familiar with, that you manage with Jira. Or, it's which are the architectural decisions that are still to be made. So the architect need to maintain that. What do we need to decide about? What do we need to design? So where does that come from? Well, that comes mostly from looking at in the requirement what is architecturally significant. So you need to do some architectural analysis, understand the requirements, and get them fleshed out if they're too primitive and not detailed enough. Understand the context, bring new ideas from outside of the system. The company may have some architectural asset. There may be some architectural elements that are reused from other projects. And then you do architectural synthesis. You make some decision, you add to the architecture, and then you evaluate this. And you evaluate it by actually running it. And this architectural evaluation will bring back things to your backlog. So it's really an iterative process where week after day or week after week, you prioritize which design decision you need to make about the architecture. You make that decision, you implement that decision in order to validate it, and then cycle back. So remember, it's about making decisions. It is about design. And I came to summarize many years ago the life of a software architect as a long and sometimes painful succession of suboptimal decisions made partly in the dark. In the end, when you look at the system, it's easy to say, oh, why didn't you do this? Or why didn't you choose that? Or why didn't you pick this? Well, because you had to make decisions one after another. You cannot just lump all the decisions, do nothing, climb on the mountain and come back down from the mountain 3 months later with all the design decisions. The architect will be responsible for some documentation. I encourage people to develop a software architecture document, which must be relatively small, but also derive from the architecting work some design guidelines and programming guidelines. You may have architectural prototype, you may have PowerPoint presentation about the architecture. You may have little extension or appendices to the software architecture document in the form of technical notes that document the reason you've made some choices. And in the system, to document the structure of the system, you may have multiple views, which may be expressed in different graphical language and textual language. So the architects are not just hands-free. They actually own a certain number of documents which they refine and evolve over time. Back to my example on the Canadian air traffic control system. First architectural iteration, we picked 4 critical use cases: entry of a flight plan, entry of a clearance, entry of a position report by a controller, reception of a radar position report. This is really at the essence of what an air traffic control system does all the time. If you can control aircraft, if you know where they want to go and where they are, and then you can coordinate between all the aircraft for who does what. And this is sending a clearance. A clearance is basically an order from air traffic control to a pilot. So what did we do with these 4 use cases? We selected a certain number of ready-made products, basically a sort of framework to develop the system. And part of that framework was also the GUI framework that would be used to develop the graphical user interface for the air traffic controllers. We didn't do much in that first iteration because there was a steep learning curve. We had to bring all the team together. We had to agree on a common process. We had to brief a lot of the developers and the architect on air traffic control, bring them up to speed with the domain. We had to teach them the programming language ADA and the development environment that was new. And the design method that we used was new for most of the developers. So at the end of this 6 months, we had only 10,000 lines of code. Pretty small, and some test harnesses and things like that. But at least we had quite some architecture already in place. The second iteration, we added 20 critical and important use cases, not complete use case, but important scenarios within those use cases to have a better coverage of the functionality. And then we started to put some key mechanisms in place about error handling, distributed object across multiple workstations, mechanisms for different mechanisms for persistency, time management. And at the end of that 6 months, we had only about 50,000 source line of code developed. And we continued like that. The third iteration added 55 use case, sorry. The requirements were finalized. Remember that we were rebuilding the requirement in the form of use case and non-functional requirement documents. More mechanisms were put in place, how to interface with a database, fault tolerance mechanism, what's happening when a workstation dies, when a communication link dies. And we tried to assess that we had a complete architectural coverage, that all of the other use cases, and there were probably a few hundreds, could be actually implemented on the architecture that we had. This is a 1.5 years into the project. And the following iterations followed the same pattern, just adding more use cases, adding more scenarios of existing use cases. And the architect had to do some touch up. Some subsystems became too big and were to be split. Some subsystems were merged. Some processes were merged. The object specification got some finer granularity. We added mechanism to make the system more portable, more understandable. We added mechanisms to allow simulation so that we could train junior air traffic controller on a simulator, parameterization of the system so that we could deploy different systems with the same code base. And the interfaces between the subsystem had to be stabilized. So how do you do this when you want to be agile? Well, what is agility? Agility is the ability of an organization to react and adapt to changes in its environment faster than the rate of those changes. So behind agile development processes, there's two key principles. Feedback loop. You need to be able to reflect on the business, on the requirements, on the risk, on the process, on the people, on the technology. So you need to build up feedback loop. And in order to build up those feedback loops, you need to have shorter time frames. So this concept of sprints or iteration. But there's also communication and collaboration. You need to speak to various parties much more often, and you need to coordinate the work on a daily basis. And because you cannot do this by using a very bureaucratic process, you need to build trust. Now, how you do agile development, it depends greatly on the context. It depends on the size of the system, the age of the system. Is it greenfield development, brownfield development? A critical system, it's more difficult to be very agile. It depends on your business model. So use the 8 ones to define that. How do you become a software architect? And is there some architect certification? And is there an architect toolkit? That's some of the questions that I got from previous cohorts at ISAPS. I'd like to say do a CS degree or something like that, but make sure that you're complementing your CS degree with communication skills. That's pretty important if you want to be a good architect. Knowing a lot of things about a lot of technology and having a fantastic GitHub repository to show to employers is good, but you'll need to be able to make a 2-minute presentation, a 15-minute presentation, a 4-hour presentation on the topic of architecture. You need to be able to adapt to your audience. What do they know already? What jargon do they use? How can I cross the boundary with them? You need to be able to negotiate things, not just impose your will or get the will of others imposed to you. You need to be able to manage meetings efficiently. That's a skill that's not taught in the classroom. And you need to be able to write clearly, concisely, because you cannot just trust people to carry on your architecture based on what you told them in front of a whiteboard. So, maybe the concept of product owner that's promoted by Scrum. Well, I would say you need to have an architecture owner in a software development team, somebody who runs the role of the architecture. So the software architect, it's more than a person. Okay, it's a role. So you need certain competencies, skills, responsibility, activities. The importance of the architect varies greatly across the spectrum of software development processes. A large greenfield project will require an enormous architectural effort. A small project that is just an extension of an existing project may not have any architectural impact at all. So you'll have to look at size, novelty, criticality, volatility of the system to decide how much software architecting you need to do in your project. Remember that the architect, if you have people playing that role, they will play some key role in communication between the 3 key entities that exist in all software project: management, definition of the project, the business analyst, the requirements engineer, and development.
I am the architect. I created the matrix. I've been waiting for you. The first matrix I designed was quite naturally perfect. It was a work of art, flawless, sublime, a triumph equaled only by its monumental failure. I have since come to understand that the answer eluded me because it required a lesser mind, or perhaps a mind less bound by the parameters of perfection.